This is class number 6. Hello friends. So this is class number 6 and we are covering the Indian geography, and earlier in 5 classes we have covered a lot of topics from monsoon to forest resources to soils, and we were doing the physiography of India. We did peninsula in last class, and today we will cover the remaining topics of the physiography of India, and this includes remaining topics that are left. Number 1 is the plains of India, Great Plains. The second one is the Himalayas, and third one is the island territories. So these three topics are left in physiography of India, and we will do all these three, try to do all these three. So let us start with the first one, that is the plains of India. So Great Plains of India. Right. So सबसे पहले थोड़ा brief, and the brief is that the Great Plains of India stretches from Indus Basin and extends up to the Brahmaputra Basin, and they are somewhere 3000 kilometers in length, and their width stretches from few hundred kilometers up to 500 kilometers, right? They are the most recent in origin, the number one most recent in origin. What I mean by more recent in origin is that they are not older than Pleistocene, right? For example, the peninsular India is lot older than the Great Plains of India. Okay, so they are most recent in origin, and they have the ravine deposits. Along with the ravine deposits, not ravine deposits, sorry, riverine deposits, not ravine, riverine deposits, the deposits which are brought by the rivers, riverine deposits. But along with riverine deposits, they also have marine deposits. Right, and we will see how they are both segregated, both riverine deposits and the marine deposits, right? And there are theories to explain the formation of the Great Plains, right? So let us start with the first of all how they are formed, okay? Because it is important to understand before we start dividing the Great Plains. It is important to understand that how the Great Plains are formed, which is the what is the procedure, okay, that led to the formation of the Great Plains. Okay, so moving to the next, that is the process of formation, how they formed, how the Great Plains formed. So what happened, that Indian plate, when Indian plate was going beneath the peninsula, beneath the Asian plate, Eurasian or Asian plate, there led to the formation of Himalayas, right? And these Himalayas, we will do it in a bit detail that how these Himalayas are formed. But first, you just keep this in mind that when Indian plate was going beneath the Asian plate, there led to the formation of Himalayas here, right? And these Himalayas led to sagging of this plate. The Asian plate got sagged. Okay, this is called the sagging, right? Sagging of Indian plate. Okay, and the two factors can be said to be responsible for this sagging. Number one is the load of Himalayas or weight of Himalayas, right? And the second one is the underthrusting. Okay, under thrusting of Indian plate. Okay, Indian plate under thrust below the Asian plate. So this is the Indian plate here, and here is the Asian plate. Okay, so this under thrusting led to the sagging of the Indian plate, and here this basin was formed, right? Now what happened? The basin was filled by sediments, but the filling of the sediments into this basin happened in two ways, two processes. So the first process number one was the filling of this plain by the marine sediments. That means when the sagging happened in this manner, water from the oceans, one from the Arabian Sea side, other from the Bay of Bengal side, the marine water filled this sagged part, right? And this sagged part was filled by the marine water, and this marine water evaporated and led to deposition of for this marine sediment here, right? So the lower part of the Great Plains are filled with the marine sediments, right? This was the process number one. After that, what happened is the deposition of the riverine sediments, right? Once these marine sediments were deposited, the descending rivers from both Himalayan side. So this is the Himalayan side, and this is the Vindhyan plateau. So let me make it again this diagram. So this is something shape of this thing. Here you have the Vindhyan Himalayas, right? Sorry, Vindhyan ranges, right? And here he let the formation of Himalayas, right? Now in this sagged part of the Great Plains, there was deposition of the marine sediment, right? There was deposition of the marine sediments. Now after that, there was descending streams from Himalayan side and the Vindhyan sides, and these descending streams led to deposition of the riverine deposits in this part, led to formation of the, that means the upper part of the Great Plains was being deposited by the riverine sediments, and the lower part was deposited by the marine sediments. So this was the procedure, that how the Great Plains were formed. Now after that, it is important, now let us divide the Great Plains first, right? That is, so this is something shape here of North India, right? So what we will do is we will divide this part of India. Okay, this is the Indus Plain that we will study. This is the Indus Plain, right? This is the Upper Ganga Plain. This is called the Upper Ganga Plain. This is Indus Plain here, right? This is the Upper Ganga Plain, right? This is Middle Ganga Plain, and here you have the Lower Ganga Plains, right? And we will study each of these four in a bit detail, right? So let us first start with the Indus Plains. So The first is the Indus Plains. Indus Plains, right? See, Indus Plains are formed by, see, they can be divided in many subparts. Number one is the Chaj Plains, Rachna Plains, Bari Plains, Beast Plains, right? So these Chaj Plains are formed by the river Chenab and Jhelum river, right? Rachna Plains are formed by the Ravi river and the Chenab river, right? Bari Plains are formed by the Bias river and the Ravi river, and the Beast Plains are formed by the Bias river plus Satluj river, right? But if you will see the Punjab plains are mostly the Beast Plains. These Chej, Rachna, Bari, they are most of the part of these plains falls in the Punjab province of the Pakistan, right? But we will more concentrate on the Beast Plains because they are the main, the your Punjab plains, right? So we will study the Punjab plains, okay, as a part of your Indus plains. So first we will do the Punjab plains, okay. Punjab plains are mostly the Beast Plains, as we earlier said, okay, Bias and Satluj, right? They are largely Khaddar, okay. The riverine plains are divided in two parts, Khaddar and Bangar. Bangar are the old elements, Khaddar are the new elements. For example, this is the valley of a river, and river is flowing in this valley, right? So this part of the floodplain, this new alluvium, is called the Khaddar, and this old alluvium is called the Bhangar. Okay, old floodplain. Second, next part is the Punjab plains are the dry plains, right? And the plains of the Punjab have bad drainage or the bad topography. Okay, bad drainage because of basin shaped topography. And because of this, what must be taken care is that you do not over irrigate these plains. But what happened in the green revolution, that these beast plains were over irrigated, and this over irrigation, this led to the salinization of the Punjab plains, right? This led to salinization in the plains. Now the next aspect that we must, now let us further divide the Punjab plains. Okay, we are studying first Indus plains. We divided Indus plains in 4 5 subcategories. Okay, then we said that Punjab plains are mostly beast plains. Then we did lit some features of the beast plains. Now further dividing the beast plains, number one is the Manja plains. Number one is Manja plains. See, Manja plains are the most fertile one. They are most fertile ones, right? Manja one, and they are around Amritsar. Amritsar belt. Right, these are the Manja plains. Then the Malwa plains. Malwa plains are relatively drier. They are relatively drier, and they are found in Patiala, Batinda. Right. So these are the Malwa plains. Okay. Then one more plain that we must know. This is the Pathankot belt. Pathankot belt. What happened in the Pathankot belt, that this region falls in the Tarai belt or Tarai zone, right? And in Tarai zone, this zone, there is the fast descending stream from the Himalayas, fast descending streams from Himalayas, right? And these fast descending streams from Himalayas have dissected this land. These have dissected this land, and because of this dissection, this land has become a non-good land for the agriculture and the cultivation. So it is not used for cultivation, not good for cultivation, right? Okay. So these are the part of badlands. They are called badlands also, and we also did this in ravines also, right? Also called as ravines, right? So we have done the Punjab plains in a great detail. Now let us move to the next part of the plains, that is the Rajasthan plains, right? We have done the Punjab plains. Moving on to the second part, that is the Rajasthan plains, right? Now in case of Rajasthan, this is here Arauli, right? This is Arauli region. This region just west of the Arauli, this region is called the Bagad region. Bagad region. Okay. And in the Bagad region, there are certain fertile patches where agriculture can be done. There are fertile patches, right? And these are called the Rohi tracks, right? Then is this part. This is the Jaisalmer, very dry and the okay. Let us make it with a different color. Say this part, the Jaisalmer and the Barmer region, right? Marusthali Desert. Now what happened? Because now this region has the migratory sand dunes, migratory sand dunes, right? And these migratory sand dunes, along with the wind factor, okay, led to loessic deposits in the adjacent region. Led to the loessic deposits in this region. So this region in the pink color is characterized by the loessic deposits, right? And these loessic deposits also have, this region also has the playa lakes, right? Playa lakes like Lake Sambar, right? Lake Puskar, Okay, and this region is called the Marwad region. Marwad region, right? So I hope we have done the Rajasthan Plains also, and this is the categorization of the Rajasthan Plains, right? Moving on to the next one, that is okay. Now we have in Punjab and the Rajasthan. Now moving on to the Ganga Plains. Ganga Plains. Okay. So we will do the Ganga Plains now. Okay. And we will divide the Ganga Plains in three parts, as we said, in the Upper Ganga Plain, in the Middle Ganga Plains, and in the Lower Ganga Plains. So let us first do the first part, that is the Upper Ganga Plains. Upper Ganga Plains. Right. Upper Ganga Plains, we will further divide Upper Ganga Plains in two parts. Number one is the Rohilkhand Plains, and second is the Awadh Plains. Second is the Awadh Plains. Rohilkhand Plains are in the Ramganga Basin, river Ramganga Basin. Ramganga Basin, right? While Awadh Plains are in Gomati Basin, right? And now let us do some features of these plains. Upper Ganga Plains are dry plains, just like Punjab Plains. They are dry plains, and they have also the salt formations, not salt formation exactly, but salt concretions have formed here. Salt concretion have formed because of mismanagement of soil, leading to alkalinization, and this kind of concretion and the soil is called the kalar or rehe soil, right? So this is infertile soil, cannot be cultivated, right? So this is the second part. Okay, we can write about it, right? And then we can see they are again the old alluvium Bhangar Plains, not new one, not Khaddar Bhangar Plains, right? So we have done the Upper Ganga Plains. Okay, these are the properties of Upper Ganga Plains few, and Rohilkhand Plains, Awadh Plains, their basin, the mismanagement of soil because of Green Revolution part. Okay, the drier nature. Now moving on to the Middle Ganga Plains. Middle Ganga Plains. Middle Ganga Plains are in the Kosi and the Gandak Basin. Gandak and Kosi Basin. Right. They are wetter as compared to the Upper Ganga Plains. They are wetter plains. Okay. They have the meandering rivers. Rivers meander very strongly in these plains, meandering rivers here. And these meandering rivers led to flooding in this region, right? So this meandering of the rivers is main reason for flooding in this region. right? And the meandering of the rivers is sometimes so strong that something like that these bands are cut and a separate lake is formed. These bands are cut and a separate lake is formed, and these lakes are called tal. These lakes are called tal or chars, right? So you can remember this property also. Okay, so this is the middle Ganga plain. Moving on to the next part, that is the lower Ganga plains. Now, lower Ganga plains are basically in the West Bengal. They are in West Bengal, right? And in the West Bengal, there are again old alluvium as well as new alluvium, right? Rivers meander again strongly. Meandering is river. Meandering of rivers happen here also, right? And the rivers form the riverine island here. For example, while meandering, the rivers deposit the sediments in this manner because the flow of rivers becomes slow and rivers become sluggish in the lower Ganga plains. This leads to deposition of the sediments, forming a special kind of channel, and these kind of channel are called anastomosing channels, right? And if you see the example of these riverine islands, examples like Sagar Island, Lothian Island, right? Gurmar Island. These are formed just in this process, in this manner, right? Okay. So this is the lower Ganga plains in the West Bengal, and the rivers meander, forming an anastomosing channel. And these islands, some examples you can remember. Okay. And these are wettest plains, right? And again, if you move westward, for example, this is the West Bengal, something like that, right? If you move westward in this direction, in this area, okay, these plains are the older alluvium, right? They have the older alluvium, and these older alluviums, like in Bangalore, they are in West Bengal, they are called the Red Plains, RARH, Red Plains, right? You can remember this also. And this region is forms the Sundarban Delta, right? So this is the topography and the general features of the lower Ganga plains. Moving on to the last part of the plains, that is the Assam plains. Assam plains, they are formed by the Brahmaputra river, right? And they are narrowest plains, right? Every year they are flooded. Okay. Now, if you see the river valley, see this is the Brahmaputra river valley. In the north of Brahmaputra river valley, you have the steep Himalayas, right? And in the south part of the Brahmaputra valleys, you have the plateau. You have what? The plateau that is not as steep as it is in the north Himalayas, right? So this plateau, from this side of the plateau, also the rivers descend, and from the North also the rivers descend. So from north, the rivers which descend from the north side, they form the trellis drainage pattern. Trellis drainage pattern. In trellis drainage pattern, what happens? The rivers descend from the slope in parallel with, as they are seen here, right? Parallelly. And the river Brahmaputra, which flows in the Brahmaputra plains, this is prone to the shifting of channel, and this shifting of channel leads to flooding, right? So this is the Assam plain and something about the Assam plains, right? Okay, so let us move to the next part of the class, that is the Himalayas, right? So we will do Himalayas. First of all, its division. Okay, property of each division, and finally the orogeny of Himalayas, that how they are formed, right? So we will do the Himalayas in three parts. So let us first of all do a division of Himalayas, right? This is called the Karakoram ranges. Karakoram. Okay, below Karakoram, you have the Ladakh Himalayas. Below Ladakh, you have the Jaskar ranges. Right. Below Jaskar, you have the Great Himalayas. This is the Great Himalayas here. Right. Below Great Himalayas, you have the Lesser Himalayas, and Lesser Himalayas are divided. Actually, they are not a continuous range. Just like the Great Himalayas, the Middle Himalayas or the Lesser Himalayas, they are not continuous. Like here, you have the Pir Panjal ranges. This is Pir Panjal. Below Pir Panjal, here you have the Dholadhar ranges. Right. Here you have the Mussoorie and the Kumaon Himalayas here. This is the Mussoorie Himalayas or Mussoorie ranges. These are the Kumaon Himalayas. Okay. And below Middle Himalayas or Lesser Himalayas, you have the Shivaliks. So this is the Shivaliks. Shivalik is again a continuous range. So this is Shivalik. Okay. So this is the broader division of Himalayas. Now let us do the properties of each Himalaya separately. Great Himalayas, Lesser Himalayas, and the Shivaliks. Right. And then we will do the formation of Himalayas. Right. So first of all, the properties. Great Himalayas have average elevation greater than 600 meters. Sorry, 6000 meters. Right. They have the hogback structure. When you will study the faults, sorry, not faults, folds in geomorphology, then you will come across this special structure, that is hogback. So hogback structure is present in the Great Himalayas, right? Great Himalayas have this CCA. What is CCA? Central Crystalline Axis. Central Crystalline Axis. Now what is the CCA Central Crystalline Axis? It is nothing but the presence of the igneous and the metamorphosed rocks. Igneous and metamorphosed rocks. Right. So this is the CCA. Great Himalayas also have the rocks of volcanic origin. Volcanic origin rocks are also found in the Great Himalayas, right? Then Great Himalayas are also seismically active, right? So this is the physiographic division or the physiographic properties of the Great Himalayas, right? Moving on to the Middle Himalayas or the Lesser Himalayas. Number one, they are not continuous as the Great Himalayas. They are not continuous. Okay. Why they are not continuous? Because during the time of formation of Lesser Himalayas, there were strong compressional forces. Strong compressional forces. And these strong compressional forces broke the Lesser Himalayas into various separate ranges. Average elevation of Lesser Himalayas is around 4,000 meters, right? And these Himalayas have the complex structures. Complex structures like nappy structures, right? The Lesser Himalayas have displaced routes. Now, what is this displaced route? These are something like that, right? So, instead, for example, if there is straight mountain which is straight, right, there will be the route below this mountain, right? In case of the Lesser Himalayas, they are deformed because strong compressional forces, so their routes have also been displaced. Okay, so their routes have also been displaced. Okay, so we have done the Lesser Himalayas properties. Moving on to the Shivalik Himalayas properties. So the elevation of Shivalik Himalayas, average elevation is around 1000 meters, right? They are youngest ones. Okay, the Shivalik Himalayas have fluvial sediments. Okay, they have presence of fluvial sediments and they are relatively continuous east-west. Continuous from east to west. Right. And they are the uplifted alluvial fans. Uplifted alluvial fans. Right. What are alluvial fans? You must know that when the river descends from the steep mountains, they form the conical deposits at the base of these ranges. So when the rivers descend from here, they form the conical deposits here in this form. Okay, and these conical deposits are called the alluvial fens. And as per a theory that these Shivalik Himalayas are nothing but the coalitions, okay, merger of these alluvial fens into the Shivalik ranges. So this is the Shivalik Himalayas. Now you see the Himalayas extend from east to westward, west to east, right? This is west, this is east. So there is a very significant and the stark difference between the West Himalayas and the East Himalayas. In earlier class, we did the vegetation difference between East Himalayas and the West Himalayas on the basis of the altitude. So in this class, we will do the difference between the West Himalayas and East Himalayas on the basis of their physiography, right? So here we say the West Himalayas. Sorry. So in the Western Himalayas, if you see, the Western Himalayas are broad, right? Their width extends from 400 to 500 kilometers. The Eastern Himalayas are narrow. Their width extend from 50 kilometers to 100 kilometers, right? Western Himalayas are not as high. They are not as high as the Eastern Himalayas. They are higher than the Western Himalayas. Okay, they are not as steep as the Eastern Himalayas. The Eastern Himalayas are steeper than the Western Himalayas, right? The Western Himalayas rise in number of series. In number of series, just like we saw that there are Pir Panjal, there are Dholadhar, there are Shivalik, and all those ranges. So they rise in a number of series. They do not have many series, right? They rise abruptly. Eastern Himalayas rise abruptly, right? The Western Himalayas have many hill stations. The Eastern Himalayas do not have many hill stations. They do not have hill stations. Right. So these are the physiographic the differences between Eastern Himalayas and the Western Himalayas. Okay. So we have done the properties of the all three Himalayas, Great, Middle, and the Lesser Himalayas and the Shivaliks. Differentiation between the Western Himalayas and Eastern Himalayas physiographically. Now moving on to the next concept, that is the formation of the Himalayas, right? So now we will do the orogeny of Himalayas. Okay, how the Himalayan ranges were formed. Okay, the different processes which were involved in different ranges. So we will do the orogeny of Himalayas in phases. So phase number one. phase 1 was OC collision, ocean continent collision. Ocean continent collision. In this phase, the Indian plate in OC collision, Indian plate collided with the Asian plate. At Potawar or Lato. This Lato is in Pakistan. Okay, this Lato is in Pakistan, and this collision of Indian plate with the Asian plate in Lato led to upliftment of a plateau, formation of a plateau that is called Potawar Plateau. Okay, now how this formed, let us depict it little bit pictorially, that how this happened. Say this is the Eurasian plate, this is Eurasian plate, right? Under the Eurasian plate, and this is the Tethys Sea, right? Tethys Sea, and here led to, this is the Indian peninsular block, and here this was subducting Indian plate, right? This is peninsula, Indian peninsula, right? And this was the subducting plate, right? And this whole thing led to formation of crystalline axis. So crystalline axis formed during this stage. Now when this plate, oceanic plate, was subducting, there led to coming out of the andesitic lava, and this lava formed the crystalline axis, and this crystalline axis formed the first ranges, which are Karakoram, right? So this was the first stage. In the second stage, the phase number 2, happened the subduction of the Tethys Sea. So when the Tethys is subducted, there led to the formation of Tethyan Himalayas, okay, or Tethys Himalayas ranges. Okay, and these Tethys Himalayan ranges are nothing but the Ladakh and the Jaskar ranges. Ladakh and Jaskar ranges. So you will see that both of these ranges have the marine sediments in their rocks, right? So this was the second phase, the Tethyan Himalayan ranges formation. So Tethyan Himalayan ranges formation, this was the Karakoram ranges. So the next to the Karakoram ranges, after the subduction of Tethys Sea, so Tethys Sea had subducted, okay, and there led to the formation of here Jaskar Himalayas and the Ladakh ranges, okay. After that, there was the CC collision. So we have done OO collision completely, the Karakoram ranges formation, Ladakh and the Jaskar ranges formation. Now CC collision, continent collision. Sorry. Continent collision happened between the Indian plate, Indian peninsular plate and the Eurasian plate. Now what happened during this stage? This stage led to the upliftment of the Great Himalayas and the Great Himalayas and Lesser Himalayas plus Lesser Himalaya formation. So you need to remember that Great Himalayas were uplifted during the Oligocene period. Oligocene period. And Oligocene period is 38 million years before present. Ago. And the Lesser Himalayas were uplifted during the Miocene period. Right, and Miocene period is somewhat 25 million years before present. Okay, so this is the CC collision. Now what happened in the pictorial in CC collision, if you see, that this is the Eurasian plate and this is the subducting Indian peninsular plate, right? So during the Miocene period, the TTC had subducted completely, and this was the Indian plate and this is the Eurasian plate. This is the Indian plate, right? And this is Eurasian plate, right? So here the Karakoram ranges, Ladakh ranges and the Zaskar Himalayas had already formed. After that, along this fault, this is called the main boundary thrust. Along main boundary thrust, there was upliftment of Great Himalayas, right? There was upliftment of Great Himalayas, right? And after that, this fault is called as the MCT. MCT, main central thrust. Main central thrust. Along main central thrust, there was upliftment of the Lesser Himalayas, right? And this fault is called the HFF, Himalayan Front Fault. And along the Himalayan Front Fault, there was upliftment of Sivaliks, right? So this was the procedure in the upliftment of the Himalayas, the different ranges of Himalayas. Now there is one peculiar characteristic also that needs to be understood before. Let us clear this only. Okay, we have to clear this first. So in case of the Himalayas, there were formation of two syntaxial band. What happened that the peninsular India is characterized by two syntaxial band. One outcrop is on this side, that is of Aravalli. This outcrop is of Aravalli. Okay, and this outcrop is of Meghalayan Plateau. Okay, and these both outcrops and both are formed of the Archean rocks. Archean rocks. So these rocks are more stronger than the sedimentary rocks. So Archean rocks are stronger than sedimentary rocks, and this nature of these two sides, east and west, led to formation of syntaxial band. Okay, so one syntaxial band is in the west, another syntaxial band in the east, right? So you need to remember these two syntaxial band also, right? Okay, so we have completed physiographically the Himalayas, right? So physiography of Himalayas, division of Himalayas, the properties of all three ranges, and the formation of Himalayas, the orogeny of Himalayas. Now we will do a practical question, that is the impact of global warming on Himalayas. More particularly, we will do the impact of global warming on Western Himalayas. Right. So, what is the impact of the global warming on Western Himalayas in terms of whether it is rainfall or in terms of vegetation, temperature increase, glacial melt, all those things? So, the first aspect of the global warming is the temperature increase. Temperature increase. So, there has been increase of temperature of around 2 degrees centigrade on average in Western Himalayas. So the maximum and minimum, if you ask, the maximum temperature increase has been recorded up to 2.8 degrees centigrade, and minimum temperature increase has been witnessed up to 1 degree centigrade. So this much temperature increase has been witnessed. Okay, and the maximum temperature increase, if you ask in terms of the ranges, has been witnessed in Pir Panjal. So maximum has been witnessed in Pir Panjal ranges. Pir Panjal ranges. And the minimum temperature range increase has been in the Karakoram ranges. The reason for the difference between the maximum and minimum increase, that is why there is maximum increase in Pir Panjal ranges and minimum increase in the Karakoram ranges, is still being understood. Okay, not clear that why this is so much peculiarities there in between the two ranges, right? So this is the first aspect, that is the temperature increase. The second aspect is the of the global warming is the snowfall. If you see the snowfall days, the average snowfall has decreased. Okay, and the maximum decrease is in again in Pir Panjal ranges. Right, and the minimum decrease in the snowfall is again in Karakoram. So if you see in terms of figures, between 1970 to 2007 and 8, in Pir Panjal, the decrease in the snowfall was 280 centimeter. Right, while in case of Karakoram, in the same period 1970 2008, in Karakoram the decrease in snowfall was of 40 centimeter. So this much is the difference between the two ranges. So this is the first thing, snowfall. The third aspect of the global warming that we will do is the precipitation, the rainfall days, precipitation days. Okay, the number of rainfall days have decreased. And this again, the number is not uniform because there is no trend recorded in the western disturbances. So western disturbances have shown the most peculiar trend in the different months, from more particular in the April to May month. So because of this, there is no particular trend, but on an average, number of rainfall days have decreased, but the intensity of rainfall has increased. Intensity of rainfall has increased. right? So this is the rainfall. Moving on to the next aspect, that is the glacial processes of the global warming. The fourth one, the fourth impact of the global warming, that is the glacial processes. There has been fast melting of the glaciers, fast melting of glaciers, right? And this has led to the many hazards. What happened? Hazards in the form of the glacial lake outburst floods, GLOFs, right? For example, in 2013 Uttarakhand disaster, right? Along with this, there is fast retreat of glaciers, right? So this is the next aspect of the global warming. Okay, now the fifth one, that is the impact on the biosphere of the Himalayas. Now what is happening in the Himalayas? There has been upward movement of vegetation. There has been upward movement of vegetation, right? Plus, because of global warming, there is increasing threat of invasive alien species. Invasive alien species, right? Like Parthenium. Okay. Plus, what is other effect on the biosphere of Himalayas because of the global warming? Okay, we are witnessing increased forest fires because of global warming. Okay, water stress. So all these are the impact on the biosphere of Himalayas because of global warming. Okay, another impact can also be written in the form of like effect on the anthroposphere. Effect on anthroposphere, right? What is happening on anthroposphere because of global warming? Out migration of population from the hazard areas or the vulnerable areas. Okay, reduction of resource base, whether it is glaciers or the biospheric resources. Okay, increasing population pressure, unsustainable tourism. So all these are the impact of global warming on the anthroposphere. Okay, so moving on to the last part of the class, that is the island territory of India, islands of India, right? And in this we will do First, the Andaman and Nicobar. Andaman and Nicobar are of two types basically physiographically. One is the accretionary accretionary prism or accretionary wedge, and the second one is the volcanic arc. Now, how these are formed? The Indian plate is going under the Burmese plate, right? Is going under the Burmese plate. This is Burmese plate, right? And this is the Indo-Austral plate, right? When it was going down to this Burmese plate, there was formation of the accretionary arc at this point. Accretionary arc at this point, and the accretionary arc is formed of the sediments of the ocean floor. But when this plate was going down, the volcanic eruption here led to the formation of the volcanic arc. So this is the volcanic arc and this is the arc on this accretionary prism. The volcanic arc is seen in the form of the barren island, for example, barren island, right? Narcondam island. So this is the volcanic arc, and other islands are accretionary wedge, accretionary prism, right? Now, when you see the lithology of the Andaman and Nicobar, they are mostly the sedimentary lithology type, right? We have the limestone here, we have the sandstone here, but physiographically it is the rocky, most of the part are rocky. Okay, we have the cliffy edges as well, right? The east coast plains of the Andaman and Nicobar, they are broad, right? And the west coast plains are characterized by the fringing reefs. Although fringing reefs are present on east coast as well, but more present on the west coast comparatively, right? Relief feature, if we ask, they are 100 to 500 meter above mean sea level, right? And some other features like, so this is most of the features of Andaman and Nicobar. Okay, their limestone, the cliffy edges are also as well, they're mostly rocky. Okay, this is the average elevation of the islands. Okay, east coast plains are broad, west coast plains have fringing reefs. Okay, so this is Andaman and Nicobar geography. When you see the second island, that is the Lakshadweep group of islands, they are coral islands. Okay, and the Lakshadweep group of islands are situated on the mid-oceanic ridge, and the name of mid-oceanic ridge is Lakshadweep Lakshadweep Chagos ridge. When you will study the mid-oceanic ridge Indian MOR in the oceanography, then you come across this term LCR, Lakas Chagos ridge, and upon this ridge, for example, this is the Lakas Chagos ridge LCR, this is the LCR, and upon this LCR there is coral accumulation, and this coral accumulation have taken this shape. Okay, this is the coral accumulation and they have taken something shape of this kind. Okay, and on the eastern side, on this side, they are steep, the edges are steep as compared on the western side, and there is the formation of atoll, and this atoll is the main tourist attraction of the Lakshadweep Islands, right? Other features, the height not more than 2 to 5 meter above mean sea level, right? The lithology we have told, mostly the limestone because of the coral nature, right? So this is the Lakshadweep group of islands, the main geography of Lakshadweep Island, that how they are formed and where they are situated. Okay. The next group of islands on the east coast islands, east coast islands. East coast islands are basically the sedimentary deposition based islands. They are sedimentary islands. Okay. Mainly formed by deposition of sediments from the river. Deposition of sediments from rivers. Right. Example: Hope Island, Sarihari-Kota Island, okay, Sagar Island. But they are not just from the deposition of sediment from river. Along with the rivers, the marine waves or the sea waves, right? So sea waves are also responsible for formation of these east coast island. For example, Sarihari-Kota. So these are the some east coast islands, right? And the lithology is mainly sedimentary. Okay, there are, in terms of lithology, mainly sediment lithology, like there is the sandstone islands. Okay, there is limestone island on east coast. Okay, there is shale islands. So this is the lithology, right? This is main lithology here. So these are the east coast group of islands. Now when you see the west coast of India, from Gujarat to Kanyakumari, okay, here also there are number of islands on the west coast, but these islands on the west coast, they are either basaltic or granitic in origin, right? Example: Eliabet Island. Along with this, we have the Diu Island. Okay, you can also mention the Bassein Island, Salsette Island. Okay, so these are the west coast island and their lithology, right? So these are the islands of India. So we have covered all three topics basically. First is the plains, second one is the Himalayas, right? And third one is the island territories. Okay, so this was the last of this class, and in the next class we will start with the drainage of India. So the topic of next class would be drainage of India. Okay. So next class would be class number 7. Okay, so meet in the next class. Thank you and subscribe the channel.